Hello everyone, James here, going over eighth grade math problems. Hope everyone had a great break, and let's get started. Today I plan on talking about how to estimate positive square roots. The definition of a square root is a number that when multiplied by itself gives you another number. On the right side here I have a chart that goes over the squares of 1 to about 50. One, sim- Simply put, the way this is represented is simply saying 1 to the square of 2 equals 1. So 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4 equals 16. 5 times 5 equals 25. All the 2 up here is doing is an exponential form of representing a square. Now, this is the sign of the square root. One thing you have to keep in mind is when you multiply two square roots with the same numbers inside or the same variables inside, it will give you the number or the variable inside, which in this situation is a. If the square root of a equals c, then we could say c to the second power equals a. Similarly, if we said the square root of a equals c, another way of representing it. So in this situation, we have three ways of representing the square root. This is in the terminology form, the word form. Square root of a is also the same thing as saying the sine square root with a inside. And this is also saying a to the exponential power of 1 over 2. And I plan on showing more examples as I go on with this different ways of writing it. So, let's get to the meat of what we're talking about today, which is estimating imperfect squares. When estimating the square root of a non-perfect square, the idea is to find the two closest square roots and then deciding which square root is closest to the given number. From the square charts, we can see the perfect squares. As I mentioned before, these are the perfect squares from about 1 to 50. Example, the square from the previous slide, which I was talking about the different ways of representing it, we saw that when we multiply two square roots, it's usually either the variable inside or the number inside. So in this situation, we have the square root of 4 times the square root of 4. Basically, the answer is 4. Similarly, with any other numbers you multiply in this format, where the numbers or variables are the same. And variables are just a way of representing numbers in letter form. Previously, we saw a. So, in case that becomes very confusing, variables are just ways of representing numbers in a letter form. Another way of representing the square root would be the square root of 4 equals 2. This is another perfect square. And remember, this could also be squared to give you what's inside here. So 2 squared equals 4. Similarly, the square root of 4 is just 2. Now, in the multiple ways of representing square root, this would be in the terminology form, the square root of 4, which could also be the symbol of square root with 4 inside, which could also mean 4 to the exponential power of the half of 1 over 2, which all is just going to equal 2. So this would be an example of imperfect square. As you can see, we're asked to estimate the square root of 20 to the 10th place. And if you're not familiar with the 10th place in the decimal form, the 10th place is simply the first letter after the first number after the decimal place. And the 100th would be two numbers after the decimal place. So we're asked to estimate the square root of 20 in this situation, when we look at our chart, or if we remember our 1 to 12 squares, we would know that the square root of 16 is the square root of 4. Yeah, the square of 4 gives us 16. The square of 5 gives us 25, which is basically where the square root of 20 falls in between. Because we know the square root of 16 is 4, the square root of 25 is 5. So we know 4 squared is 16 and 5 squared is 25. So the idea of finding the estimate is basically looking at the squares and comparing within the spectrum what's in between both of those numbers we're trying to get to. So we know 4 squared is 16. We know 25 squared is 25, and we know what we would like to find is the square root of 20, which is in between 16 and 25. In the square root dynamic, we know 4 squared gives us 16, and 5 gives us 25. And we know 4.5 is right in between those two numbers, which could get us very close to 20. So basically, the way of solving this is knowing the numbers that are going to be squared that are close. So using this number line, you start off with this part, which is understanding 4 squared and 5 squared gives us the number we're looking for, which is the square root of 20. And when we look at the decimal points in the 10th place, which is going to be 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9, and then get to 5. The number in between it being 4.5 gives us the best estimate of the numbers in which the square roots are being equated to. So 16 and 25, the number between them is 20, and 4.5 is the easiest way to estimate the square root of 20. Now for the second one, we're asked to estimate 160 to the 10th place again. Now, when we look at our chart, we know 12 squared equals 144 and 13 squared equals 169. What we're trying to find is something in between 12 and 13 that's going to give us 160. Now we know 12 gives us 144, and we know 13 squared gives us 169. Now when we look at the numbers in between those, we could see 156. Now, in knowing that 156 is the number in between this, we could always build from there. We would know that 160 is right here somewhere, not too far, but right here somewhere. Now, similarly, when we go down here to the numbers being squared, we see that 12.5 is roughly a good estimate between 12 and 13. And we know the number we're looking for would be right here for us to be able to get that 160. So in saying that, since we're estimating, we could roughly say somewhere right here would give us 12.7. So, and that's kind of the logic behind it, right? So when we look at everything we've talked about regarding the squares and the square root, we know that this is the square, and while we're going backwards is where we get the square root. So in saying that, in this situation, we looked at the two numbers that would square roughly to the number we're being asked to find, because we know 12 squared equals 144, 13 squared equals 169, which that 160 is right in between both of them. So, yeah. Thanks again for joining me. My email address is right here. If you guys have any questions, please feel free to reach out to me. I'll definitely try to get to the messages as soon as possible.